here, you can see it's about 400 computation is to have a conversion related to 1.11%. So this number we obtained from the reliability analysis of applying our modified proposed method. And for another case, such as in this, we also consider this and it have less number computation. And you can see here for another case, the number computation is, for example, when the failure probability is so small, it needs to have a very significant computation. Although we compute with 4 computation in each iteration, so it means we can divide it by 4, so about 150.
Not exactly my question, but it's not so important. So, thank you, Mr. President.
Donc, vous avez la parole à Daniel.
Thanks, Mr. President. So first, thanks to your work and thanks to the supervisors to call me for this task. It's a pleasure for me to be there with you. So I will begin by the oral presentation. Yeah? So I like the first slides where you present CGO and the underground work you consider during your PhD manuscript. But then it's very dense. Means that you set a lot of figures, like this slide. Are you sure that it's interesting to set all these figures? Is it really necessary? The idea of the PhD defense is more to present the main results of your work. Here you try, I know that you have done a lot of work, yeah? So probably you miss a little bit the fact that you are here just to present the main results, not all. Okay, it's too much. Remember, it's too much. For me, it's too much. If I have the chance, to read the manuscript, so I can more or less understand what you are saying. But in my mind, it's too much. So probably next time, better to try to summarize and, for your next presentation. It's 2 minutes. For me, really, it's 2 minutes. So it's my first. And then the second comment is, probably you can reduce a lot the number of results you present by the fact that you are only doing comments on the figures. We need more things. We need why it happens and why it will give physically. Yeah, what is the physical aspect of this part? Yeah, it lacks, your presentation lacks a little bit of this, of the physical. Yeah, the physical meaning of this and this. Yeah, so try to go in this direction. Yeah. So for the oral presentation, more or less okay. Let's now go back to the manuscript. So on the manuscript, I have noted some remarks. The first is page 38. So I will try to illustrate sometimes with the slides, but this one is not illustrated. In page 38, you took one stopping criterion, condition, which was the convergence of the probability failure estimate. In my mind, we should add at least another criterion like the variance or the error of the probability failure. Yeah? Did you try it? Did you try to add the error of the probability failure?
Sorry, with page?
Page 38.
30.
Yeah. You only, so I try to read. You only worked 33 things.
No, 3.
3, 8. Yeah.
Ja, ja.
Okay, here you only deal with the your criteria is the convergence of the probability failure estimate. Yeah? But you know that you can add other criteria, like the variance of the or the error of the probability failure. It will be better. So next, if you have to do more calculations, think about that. Yeah, it's okay to work with this stopping criteria, but in my mind you can add a better, you can have a better accuracy using the error or the variance of this probability failure. Yeah? Page but it's more or less in your slides. You say in your document you say that you didn't consider the initial stress state as an uncertainty source. So I was wondering, my question is, the excavation will be done at 500 meters depth. So are you sure that the density of the rock will have no influence?
Yes. So,
You never took the volume weight of the rock as an uncertainty parameter. Are you sure that at this depth you will have no influence?
at the moment, I have no idea about the density. Maybe I will consider it more in my next study.
Okay, it's really a question. I'm not sure, but I know that in geotechnical problems, it's not the main parameter, but it always has 10-20% of influence. So it's not, usually I consider it. Yeah? I'm not sure that in your work you will have to consider it, but if you check in the literature, a lot of authors consider it as uncertain. Yeah? And then you have to go to slide 20. So you say that, if I remember, you say that you have worked with normal distribution.
Right.
Yeah? In fact, I have a doubt due to two reasons. The first one is the fact that if you check your distributions, they are not really normal.
Right. It's not.
In my mind, they are more non-normal than normal. Yeah? So, first reason. The second one, I have just done a small calculation, and so if I check your property, you took a young modulus of 6 gigapascal with a standard deviation of 3.5. So, I just calculate the probability to obtain negative values. And you have 4% of the probability to obtain negative values for the young modulus is more or less 4%. It's a high level. So in my mind, using a non-normal distribution will be better. Like that, you will not have negative values. Yeah. And probably you will be able to respect a little bit more the real shape of your experimental level. Yeah?
You're right. And in fact, that I also consider the log distribution, as you mentioned. And
That's good.
yes, you can see over here, I will show you this. It is when I found out this must be used in the Lachman distribution. So we compare it with the Lachman distribution. As you can see here, the Lachman in the off-range curve when the Lachman distribution is in blue, is have a significant when the value is 30, but in almost case is quite similar. And for we also consider with the threshold as well as the thickness as well as the filament rate. It has some after we consider all case in the Rachman distribution, we found that it has not, for example, in this case, it changed a little bit in probability of value. As you can see,
The graph, the small graph, what is that? It's also a problem. The horizontal axis, what is the horizontal axis? What is the vertical axis? I cannot understand.
it is a zoom. It is a zoom of this part.
Okay, it's a way. Okay.
But it's small.
Yeah, but the influence is big. It's more than 60 to 70%.
In this case, I consider the difference of epsilon V2 not compared to the Rachman in only this slide compared to the Rachman distribution. And for this slide, I consider all case in Rachman distribution with the effect of the compressibility between as I said before, there are two types of factors that strongly affect to the stability of long-term tunnel. That is the ABC parameter and this value, the compressibility of the first liner, and I consider it in.
Okay, my main remark is if the data you have looks like to have a log normal distribution, please use the log normal distribution. In your oral presentation, you say at the end of slide 20, you say it's why I have used the normal distribution.
At current manuscript, I use Rachman distribution as you said, but I think I can change if I can change all application of Rachman distribution to the Rachman.
I don't know. Be careful with that.
If I can.
Your data looks like a non-normal, so at least add a figure which shows that using a non-normal distribution is better. Yeah? But your conclusion is you say that you use a normal distribution. Not so good in my mind. And if you check the literature, you will see that a lot of people say that normal distribution is not really good for humans or for geometric parameters. Yeah? Okay. So when you decide to validate your new method, the new reliability method, the new AKMCS, you just have validated it in one case. Yeah? In your manuscript, I only saw one validation. In my mind, you have also other data which can be used in section 242. You have done a lot of calculations using the crude Monte Carlo simulation. So you can also use this data to validate your new AKMCS method. Yeah? So it's section 242. You have data that you can use to do a complete validation of your new method. 242. So in my mind here, you can use it for the validation of your new method. Page 108. You say we assume that all the random fields have the same value of correlation length. Are you sure of that? What are the arguments, or did you check in the literature if people have found this kind of results? It's not necessary to read, please. And there. You say we assume that all the random fields have the same value of correlation length. Yeah?
They say the same.
Do you find something in the literature which shows that, or how do you take this assumption? Why?
That's firstly we consider it share the same correlation length because if we select for example A with this correlation length, B for another correlation length, and C and so on. This is why complexibility. And first case we must consider the variability with the same correlation length firstly, and that's why as in our proof, in my perspective, we consider it with the correlation length, different correlation length.
Okay, that's it.
Yes, as you mentioned.
What data will you use to define a different correlation length? What will you do to obtain the number?
Right. As in the moment we don't have any exact of the correlation length, so we propose, we assume to use as small as we can have. For example, as you can see, firstly we select 15 maps. If we we want to consider it with 5 maps, 5 meters of correlation length as small as possible. But at the moment we consider it with 15, we have only 2 random fields. So it have nearly 50 random variables. It is nearly maximum capacity of our computation. So that's why we need to modify or to use another approach called the AKHTMR.
Okay, so you optimize your calculations by decreasing the complexity. Okay. Okay, better to say that, yeah? Till now, I didn't have the good reliability method to do better. Okay. In the text, your manuscript, you say that the IK, so the classical AKMCS, can only be reasonably applied when the maximum number of variables is more or less 50.
Yeah.
Yes, that's in a lot of sentences you say something, but we don't know why you say that. Means that when you say something like that, you should have references or people who have already worked on this kind of problems, and they show that 50 is the maximum. And really, I checked in your manuscript, and I cannot find a reference or something. It's like you decide that it's 50.
In fact, that I found in the literature, but also I have some results that prove it is right, because as you can see, when we consider 2 random fields, it's really hard for me to for my CPU, and it's and when I try to compute 100 of random variable, it takes more than a month. It run and it's not converged. It takes a lot of time to use it and decide.
Try to separate the problem of CPU. Yeah, it's not a theoretical problem, and the problem of convergence. Here we should more focus on the problem of convergence. Yeah, CPU. Okay, we can next year probably. Dashboard will buy you a better computer, and that will be able to do that. Yeah. So now I don't. Till now, I really do not have the reason of why it's 50 or 60. You should show it. Yeah? If you say something, you should argue why. Yeah, you say that. And in a lot of sentences, it's not so easy. You say things, but it's like it's logical, easy to understand. Yeah, you should argue and say I think it's due to this reference or something, yeah? Or I have done some calculations, and it's clear that they cannot converge for more than 50. Yeah? Try to be more accurate. Yeah. So in section 445, you consider a problem with 24 random variables. So it means that the technique you propose can be applied to 24, yeah? But you know that 24, it's not a high-dimensional problem. High-dimensional problem, it's more 100. In the literature, people will say, oh, it's more than 100. So, what will you do if you exceed? So, till 24, it's okay. Did you investigate to how many random variables you can use with your technique? Did you try to go ahead, or you stop at 24? You don't need the manuscript in my mind. Yeah? I'm just asking you, so you have done calculations with a maximum of 24 random variables. Yeah? With the method you have used, could you go ahead? Did you try to use 50 random variables, or did you try it?
Yes, I tried.
Yeah, till which number you can go?
And for the simple case such as the elasto, which only rock mass, we have to care about the liners and the behavior of the rock mass only elastic. The number of random variable is very high. You can consider it. It can be so. And you can see here for the case of elastic, the number of computation or number of variable here is much more. Here I can calculate with 100 and
Are you sure of the accuracy with 130 variables? Are you sure that the failure probability is okay?
it is it is another approach. We use another performance function, and this is a simple case, and it is a test, another test for the geometry, and this is the number of variable, and just only jump rules. So in this case, my computation can compute much more than one.
Okay. Okay. It was not clear in the PhD. Probably last question. So, what is very nice in your work is the fact that you developed the closed form formulation. Yeah, I wrote that it's very nice. Yeah? But it was not clear what you really done. You really done. Yeah. What you bring to the model means that sometimes it's not difficult to read. Yeah. Your manuscript is okay, but we don't know what you really bring to the system. Yeah, what was really your work? You understand a formal model, you bring what did you bring? Yeah, it's always difficult. And we wanted that. Yeah, we want to know what was the things that you really implement, what is new, what were the assumptions that you consider. Yeah, so it lacks a little bit in this part. Now you finish your work, yeah? What can be really interesting now to in what part of your closed form solution you can improve? For you now, what should be the next improvement of this formulation? You give a lot of perspective, yeah? But too much in fact. You cannot work on 10 topics. What will be the more important thing to do for the next step?
You can see here in the next step, close to us, we can firstly we can complete the 2D domain for the variability problem, as I showed you in the lecture with the.
Now, are you sure that if you go to the 3D domain, are you sure that the reliability method you propose will be sufficient? The number of random variables will increase a lot in 3D. Are you sure that
it may increase the number of variables when we take into account the last side of it's in here we not only use one pattern of domain but also we use the full with one full of the circle, and we use it and I investigate it have much more number of random variables. And
so did you already have done some 3D calculations?
yeah.
Yeah?
I have some, as I said, as I showed you in the table before.
Okay, and physically, tell me what will be the next improvement, the next necessary improvement of your calculation. What is try to give a rank of all these perspectives. What will be the more interesting point to be done? And you know that the next question will be why?
I see. The first, I will select maybe the correct land, as you said, and it's so important, especially when the real weight is often about 5 to 7 meters or something, such as in the 0 foot proposed. And so we must reduce the correction depth as small as we can have. And the log distribution we will consider to take into account, and then.
How will you do that? Means that you will take several numbers and you try to check the influence. You will do like that.
Sorry?
How will you do that? Means that you told me that you want to investigate the influence of the correction length. So you will change the value of the correlation length and do the calculation.
And
are you sure that it's the good way for an engineer to it's interesting, but probably it's better to discuss with Andra, yeah, to ask them, did you have some data which permits to I don't know, try to be more connected with physical data. Yeah, real data. Yeah, I know that numerically you can investigate the value you want. Yeah, but the main thing is try to bring something to the CGO project. Yeah? My last remark. You told us that CGO will begin next year. Are you sure?
In schedule. I said in schedule. I forgot the catalog of Andra. I go to the CGO last year in the Andra conference. They have the schedule plan in 2021. They start to install the.
Okay, so it's
It's scheduled. And I said, it's scheduled.
I hope that. Okay, thanks a lot for the answer to my questions. I give back the presentation. Thank you. First, I want to thank Dr. and the people who invited me for PhD defense. I will tell that Syria will not start to escalate next year. We will apply for license and we will perhaps start in 5 years or something like this. If everything is okay. It will take a lot of time. I'm not a specialist about this type of work, of uncertainties. I'm come more from field. So we will not ask a lot of questions. You make a lot of curves about everything, about digging or velocity of excavation and things like this, which for me could be really interesting, but many times you just give the result and don't explain anything. We have the same question from Professor Deck about sometimes you go very fast and rate or things like this. I think it's important to have also some physics explanation of the result, especially for people from field. I have a question about the slide 14, if it is a good one, because it's something that yes. So you know that in excavation there is two types of excavation mostly used. One is TDM, full-scale TDM, and the other one is classical methods with a primary support and another support which is cast afterwards. It is, when you present like this is classical excavation methods, but sometimes when you speak about the compressible material, it's a material which will be used in TBM method and not in this type of method. So how your work are focused on could work for all the methods of excavation, or you see some differences in terms of excavation step, things like this. For example, in the classical excavation methods, the first liner is just here for supporting the rock for some months, for some years, and after have no effect really. It's what we want to do it. We want to let the grade converge, and after we want to cast the concrete segment or something like this inside. So what is your point of view on that? Is it used for just classical method, as you show here, or also for TDM methods?
We just consider the different time to exploration the different line. First, to line
Yes, but what is the problem that when you use the if you go to the slide, I don't remember the number, when you show the compressible material, if you just use like this, it will collapse. You have to know that. Because there is no strength on your if you put it first and after the liner a time later, it will not work. So for me it's a bit a problem that of course you speak about CGO, but also you have to take care about what is. I think you work well on mathematics, but the links with construction is not as well done from my point of view. So perhaps you have to what is, you say that it is for classical metal, but the material you use is not possible for this type of method. The compressible material will not stay.
The compressible is elastic. Sorry, it is elastic. This elastic line.
But if you check the stress in your, you make a lot of modeling. You have to check the stress. If you put the liner first, the first liner, I will show it, with the compressible material, you will see that whatever you do, this material couldn't stay stable. So it means that you don't have time in between the first liner and the second liner. So it means that you need to make a TBM excavation. You understand that? Some of the questions have been already discussed, but I will come back to the correlation length, because it's from practical point of view, if you have to, you say that it is important, in the result it seems to be important, so what you will tell to people in field, what they can do to verify or measure this correlation length. Because it seems to be a crucial parameter. So if you have to give advice to Andrea, what do you say? How you do it?
At the moment, I have no idea to give some recommendation about this can observe in or you can measure in the field, but you can see the correct length here.
This is mathematics for people from field. They will not know what is it. So what I have to say for people to measure something for them. Because one of the questions asked by before by Daniel is you say that all the parameters have the same correlation length. How we can be sure of that and how we can check that? We have done a lot of work because, for example, for young modulus and something we don't use it, permeability, we don't find any correlation. We have good correlation for young modulus and mineral contents. So we are able to give some things like this on young modulus. But for example, for quick, it's quite difficult. So what are the way to give you some good data? Making more tests or what? If there is a strategy on sample or something like this, I don't know. What is your opinion?
Don't worry, it's an open question.
Well, nobody knows.
I have an answer.
Me neither.
Did you know how can
I have no idea.
Okay, nice. Just one remark, it's about you call it probability of failure. Is it really a probability of failure? Because in fact, in what you check, it's strength about 32, 35 MPa with concrete, which are C60, 70, where the strengths are about 60 to 70 MPa. So you call it like this, for you it's a failure, but for me it's not really a failure because it's more with this level of stress the concrete will not remain elastic. But it's not, do you mean it's really, when you get the probability of failure, it really means that you will have of your concrete support, or it's more a way